Hey guys, Dr. Betts here coming at you with another fantastic chemistry video, and today we're going to be doing the Energy and Matter Lab. Now because of the shutdown of the classes at Broward College, we're going to have to do this experiment together via video. I'm going to be your lab partner. I'm going to work with you through this video. We're going to do the experiment together. Now you're responsible for writing everything down in your book. Just like you were in the lab, you have to write down your notes. You have to write down masses and volumes. You have to do the calculations. You're going to have to submit this lab report eventually. I'm not sure when because of the way, the fluid motion of everything right now. But just hang in there, guys. We're going to reopen classes, and we're going to get back together soon. But right now, we got to keep continuity going. We got to keep moving forward so that you guys can pass this class. All right? So you're my lab partner. I'm your lab partner. I'm going to do all the work, obviously, because I'm in the lab. You're at home. But you still have to write stuff down and think about what you and I, are doing. All right, guys? So let's get after it. Let's get it done. All right, guys, now we're going to have to weigh out some of the ammonium chloride for the physical change aspect of the Energy and Matter Laboratory. So I'm going to lift the lid here, put it in a weighing boat, close my lid, and then read 0. There we go. And we're going to use, see if I can give that to you, ammonium chloride. There's the stuff we want to use right there. It's a white granular powder. Open the lid. We need right around 2 grams. It doesn't matter if it's 2 grams exactly. It's got to be in the ballpark, and we have to just know the exact mass. Well, not the exact mass, the precise mass. Getting there, getting there. Look at that. Pro move right there, guys. Pro move. Let me close the lid. And there it is. There's our mass. Hopefully you can see that on the computer screen. Let's write that down. I'm trying to find a pen here in my lab coat so I can write the marker down. All right, get it jotted down, guys. And let's move on to the next step. Hey guys, Dr. Betts back again. Now we're going to do the physical change part of today's experiment. I'm going to add the ammonium chloride to 25.0 milliliters of water. You might want to write that down in your notebook. 25.0 milliliters of water, and then we're going to monitor the temperature over time. In a 10-second intervals, I need you to write the temperature down. I have another camera set up, focused on the thermometer so you can see it, and you have to write these temperatures down in your notebook. It won't be hard. Just keep your eye on the camera and write all this stuff down in your notebook where it says trial number 1 for the physical change part of the experiment. Okay, guys? Here we go. I'm going to add some water here now into here. And I left my ammonium chloride on the bench, so I'm going to go over and get it. Right back. See, just like a real lab, people mess up. Got to go get their stuff from somewhere else. All right, I got it off the balance now. Here I come back again. Okay. Now, the temperature of the water, and you're going to want to write down initial temperature degrees Celsius, is 24.0. 24.0. And I'm trying to focus my other camera here. 24.0. So now I'm going to add the ammonium chloride. And I'm going to swirl. Okay, I'm going to try to get the camera back on here. There we go. All right, guys. Call that 10 seconds. Ten seconds. So now you're at 30. Notice the temperature is not really changing much now, but it certainly dropped a bit. Okay, write your temperature down one more time. All right, again. Wait. Here we go. It's getting close. Okay, again, write it down. Getting close. Temperature's not really changing much anymore. The initial temperature change is the most drastic one. And there is another 10 seconds. Let's go 10 more for good measure. And there's a minute. All right, guys. There's your time trial number 1 with all your temperatures and all that other stuff done. So that's time trial number 1 or trial number 1. You wrote down the temperatures and over time. So we're going to set up now for trial number 2. Same thing, just going to do it a second time. All right, guys, here we are ready for time trial number 2 for the physical change aspect of the energy and matter labs. This is trial number 2. Make sure you write all this information down. We're going to time it. We're going to take temperature recordings every 10 seconds. All right, the water is already in the calorimeter, 25.0 milliliters. So now all there is to do is get the timer ready and go ahead and add the material. So temperature at time 0, 23.9 degrees. Let me get that thermometer nice here for you guys. 23.8 degrees, I guess it says. Here we go. Add it in. Start the timer. Swirl, 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 swirl. Get everything nice and mixed. And then put the thermometer back so we can see it. There we go. And I'll tell you 10 seconds. Write it down. Write that down. Write that temperature down. 10 seconds. Keep it. Come on. Here we go. Come on, come on, come on, come on. Here we go. Here we go. 20 seconds. $30 seconds. Here we go to 40 seconds. Coming up on, here we go. Get ready, ready, get ready. 50 seconds. And this is a minute. Write that down. Write that temperature down. All right, guys. So there is the end of time trial number 2. And that is the end of all the experimentation that we need to do for the physical change aspect of the energy and matter laboratory. Now it's all up to you. Calculations. Go ahead and crank them out. They're not that hard. If you can't do them, let me know. We'll try our best to figure out how we're going to do this during this little class dismissal time or whatever we're calling it now. So hang in there, guys. We're all working together on this, and we're all in this together. We're going to figure it out. Okay? Stay tuned. Next part, we're going to do the chemical change thermodynamics, energy, and matter lab. All right, guys? See you then. Hey, guys. Dr. Betts back again. Now we're going to do the chemical change part of the energy and matter lab. We're going to mix sodium hydroxide with hydrochloric acid. Right now on the calorimeter, I've already got 30 mils of pure water, and I'm going to add 10.00 milliliters of sodium hydroxide, which is right here. So I'm just going to add that on in here. Boom. I'm going to turn my stirrer on to get the nice stirring going. There we go. So I like to swirl too. There we go. And now write down the initial temperature. This will be temperature 0. Let me get my book ready here so I can see what I'm doing. Okay, we're doing time trial number 1 for the chemical change part of today's experiment. 10.00 milliliters of sodium hydroxide, 30.00 milliliters of water. All right, the temperature is 24.0 degrees Celsius initially. Now, same as before, I'm going to add something to something else, and we're going to monitor the temperature. So before I added ammonium chloride, the temperature went down. So now I'm going to add hydrochloric acid to sodium hydroxide, and we're going to see what happens. So keep your eye on the temperature, guys. Here we go. Pour it in there. Start the timer. Swirl, 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 swirl. And, of course, the thermometer turned off. There we go. We'll be all right. There you go. 26.4. 10 seconds. Write it down. Here we go. Keep your eye on the thermometer, guys. There's 20 seconds. There's 30 seconds. There's 40 seconds. There's 50 seconds. And there's 1 minute. Write that temperature down. So there you go. Temperature went up for this experiment. Okay. So there's time trial number 1. Let's do it again. We're going to repeat the exact same process with fresh material to see if we get a similar or the same result. All right? Okay, guys, we're ready for part 2 or trial number 2 of the chemical change aspect of the energy and matter lab. So we're going to do the exact same thing. I got 30.0 milliliters of water in the old calorimeter. I'm going to pour in right now some 10 milliliters of sodium hydroxide. Okay. And let's get that thermometer back on there. There we go. 24.0 degrees Celsius is time 0. So before we add any hydrochloric acid, the temperature of the water and the sodium hydroxide is 24.0 degrees Celsius. So now I'm going to add my HCl. Here we go. I'll start. Let me get that back on frame there for you. There you go. Waiting for 10 seconds. 10 seconds. Write it down. Write the temperature down right there. 26.7. We're just doing time trials now every 10 seconds. Here we go. Coming up on 20. Okay, 20. Mark it down. Write the temperature down. Coming up on 30, guys. Get ready. Okay, mark the temperature. That's 30 seconds. "40 seconds." Write the temperature down. That's 50 seconds, guys. And there's a minute. All right, guys. Whoops, let me get that back on there. There you go. There's a minute. 26.7 degrees Celsius. So there you go. There's the end of all of our trials, all of our time trials. And that's all we have to do as far as chemistry goes, as far as mixing things together goes. Now you have to do all the calculations involved in this experiment. The nice thing is, the calculations are essentially the same for all 4 trials. So once you get one trial done, the other 3 should fall into place fairly easily because they are the same calculations. All right, guys. Now with that, I want to wish you all good luck and good chemistry. Stay healthy out there, guys. See you soon.